Okay, so hello everyone. In this video, we will try to analyze all the questions of weekly contest 392. So let's start. Basically, I will be solving all these four questions one by one. Okay, or maybe I will just, I can either solve these directly or I think I will just create a virtual contest. Uh, okay, okay now. So longest strictly increasing or strictly decreasing subarray. You are given an array of integer nums. Return the length of the longest subarray nums, which is either strictly increasing or strictly decreasing. Wait a second, let me just get my pen tablet. Um, yeah. Okay, so this is working now. Suppose we have these nums. So one thing I can do is I can first get the length of the longest strictly increasing, and then I can get the length of longest strictly decreasing, and then I can just take the max of them, something like that. So for example, if we have 1 4 3 3 2, then maybe I can say like dp of I is equals to longest strictly increasing subarray ending at I, something like that, and then dp of I equals to 1 or dp of I equals to 1 plus dp of I minus 1. This is if a of I not less than is not less than a of I minus 1, and this is the else case of that. So this way we can just take the maximum of dp. So something like that I can do to get the longest strictly increasing subsequence, and then I can get the longest strictly increasing subarray, and then similarly I can get the longest strictly decreasing subarray and just take the max of them. And I can even reduce the space complexity to big of 1 because I don't really need the rest of the values before I minus 1. But I don't think that's necessary because the nums dot length is only 50. So let's just code it quickly. So we have this. Let's say n10 is equals to nums dot size vector in dp of n plus 1 comma 0 or 1, let it be 1. For I in range this, uh, if let's go till n minus 1 only, if nums of I not equals to, or let's say less than nums of I plus 1, then dp of I is equals to dp of I minus 1 plus 1, or I think it is already equals to 1, so I don't really need to do this. And let's say int answer equals to 0, answer is equals to max answer comma dp of I, yeah, plus equals to dp of I minus 1, I minus 1, or should it be I plus 1? dp of I plus 1 equals to dp of I, so I can extend it something like that, and let's say dp of I plus 1, yeah. Similarly, I can again do this like dp dot assign uh, dp dot assign what, n plus 1 comma 1 again, and the same thing, but this time I will use the greater than symbol, and now let's return the answer. So this should work. Let's try to run this. So we are getting 2 for this, so the answer is 2. Let's try to submit it, and we are getting a wrong answer. The output is 0 for this one. Yeah, because I think the initial answer should be 1, right? So solution gets accepted. Let's move on to the next problem, that is lexicographically smallest string after operation with constraint. This looks boring. I don't really like to do play with strings, so I think I will just move on to the next problem for now. Okay. So minimum operations to make the median of an array equal to k. You are given an integer array nums and a non-negative integer k. In one operation, you can either increase an element by one or decrease the element by one. And we want to find the minimum number of operations needed to make the median nums equal to k. Okay. So for example, if we have this, what are the constraints? Constraints are 2 into 10 to the power 5. So when we have n equals to 2 into 10 to the power 5, it is asking for a big O of n time solution or big O of n log n time solution, right? So something to do with sorting because it is talking about median, right? And now we have 2, 5, 5, 6, 8, right? So the sorted array looks something like 2, 5, 5, 6, and 8. Okay. Okay, now and the median of an array is defined as the middle element of the array when it is in sorted order. If there are two choices for the median, the larger of the two values is taken. Okay. So we have this. Now it will depend on if n is odd or not. Because if n is odd, then 1, 2, 3, 4, 5, then there is only one possibility, this one, and like that. And if n is even, let's say we have 1, 2, 5, 5, 6, 8. Let's say if the array was something like this, then my answer will start from here. So one thing is for sure, like, okay, let me just copy this whole thing. So if we have this now, let's remove this part. So you have vector int nums. So let's first take the length of this array, and we want to get the uh, upper limit and the lower limit. So I think I should start from the first. I need to sort this whole nums array. So sort nums dot begin, comma nums dot end, right? And once this array is sorted, I need to check the minimum element. So let's say, and I need to keep increasing my answer. So let's say int I equals to 0 and long answer is also equals to 0. If nums n by 2 equals k, then I will return 0. So I don't really need to do anything if the median is already equals to k. Why this works? N by 2. Let's see. So if my length is 1, 2, 3, 5. So 5 by 2 is equals to 2, right? So 0, 1, 2, it works. And when the length is even, 1, 2, 3, 4, 5, 6. 6 by 2 is 3. So 0, 1, 2, 3. So it will point to the bigger element only. So that is why we have this. Now, after sorting, if that is equal, then we don't really need to do anything. Otherwise, now I have two choices. If k is greater than nums n by 2, then what to do? Else, then what to do, right? So let's say we have this array 1, 2, 5, 6, 6, 8. So we have something like 1, 2, 2, 5, 6, and 8. Okay. Then we are given some k. I want to make the median equals to k. Let's say if like median will be this value, right? 0, 1, 2, 3. So this value, and it is asking us that okay, we want the median to be equal to 4. So one thing we can do is decrease by 5, decrease this whole 5 by 1, right? So it will become 4. No, what if we have something like 5, 5, 5, 6, and 8? Then I have to make this 4, this also has 4 and this also has 4, right? Yeah, but I can leave this part as it is. So if it was smaller, then I have to make the first n by 2 elements lesser, and if it was greater, like if I had to make the median equals to 7, then I should try to make the last half elements just greater than equals to k. Yeah. So what I can do, if k was greater, then I should try to make the last half elements. So for iron range, let's go from n by 2 till n. Uh, Answer plus equals to uh, absolute. No, I need to make them at most equals to k, right? So let's say absolute value of num psi minus max of, I mean, but what happens when we have 1, 2, 2, 2, 2, 2, and we want the median to be 7? And what happens when we have 6, 7, 8? No, no. What happens when we have 8, 9, 10, 11, 12, something like this, and we want the median to be 7? So in this case, I want all these numbers to become 7. So 7 minus this, 7 minus this. And what if we have 10 and 11? Then we don't really need to do anything for this, right? So I should say, like, if num psi is greater than equals to k, then continue, else answer plus equals to k minus num psi, right? Otherwise, I will have to do a reverse for loop. And I also need to make sure that um this value becomes equals to this k value. The at this position k should be there, right? So that is one case, and it will also go for here also. I greater than equals to 0, and I minus minus. So now if num psi is less than equals to k, then continue. Otherwise, answer plus equals to num psi minus k, right? And in the end, I can simply return the answer. Okay, I think this is good. Now let's try to run this and see what happens. So we are getting 2 and the answer is 2. Let's try to submit this, and our solution got accepted. Let's move on to the next problem. I think I will read both of these problems and then decide which one to go for first. So we define a function distance of s1 and s2 between two strings, s1 and s2 of the same length n, so they are of the same length, and the sum of the minimum distances between s1i and s2i are characters between wait, what? The sum of the minimum distance between s1i and s2i when the characters from a to z are placed in cyclic order. Okay, for example, the distance between ab and cd is equals to 4. So between a, okay, and distance between a and z is equals to 1. Okay, and the change, you can change any letter of s to any other uh, lowercase English letter any number of times. So I think some sort of greedy approach will work here, and the length is also very small. So this should be actually easy, because sometimes when k is very large, I can simply convert it to all a's like that. Let's see this one. Minimum cost to walk in a weighted graph. So there is an undirected weighted graph with n vertices labeled from 0 to n minus 1. You are given an integer n and an array edges. Edges I equals to uv w1 indicates there is an edge between u, v, and w. Then we have a definition of what is a walk on the vertices. The cost of a walk starting from node U and ending at node V is defined as the bitwise AND of all the edges, like that. So then we have a query. We start from node S and end at node T. And if no such walk exists, then the answer is -1. So basically, if the components are disconnected, then we have the answer is -1. Otherwise, we want to walk. We want to have a. We want to find the minimum cost that we can get for reaching from S to T. Okay. So if I'm starting from 0 and I need to reach 3, I can do 7 and 7, but that will make my answer as 7 only. But I should go to 2 and then 7. So if we have 7 and 1 and 7, then my answer will become 1. So that is why we have a 1 here. And since I can't go from 3 to 4 because they are from disconnected components, my answer will be -1. So this is interesting. So one thing that I can do is probably a DFS. So if we have 0, 7, sorry, not 7, 1, 3, and 2, sorry, 7, 7, and 1. Uh, so this whole thing is single component and this 4 is a single component. But one thing to notice here, that if I'm starting from 0 and ending at 0, uh, my answer will always be 0, right? Yeah. So if I'm starting from the same node and ending at the same node, my answer can be 0. But in any other case, what are the edge weights? Edge weights are 1. Okay. No. Edge weight. Okay, so edge weights can be 0. Yeah. Okay. But if there is any edge, like let's say 5 and there is 0, then I can always take a route like this and make the answer as the minimum value. So the optimal value would be to just take the AND value of all the edges in this edge lengths in this whole component, and for any two nodes in the same component, the answer will be the minimum value for this whole component. So something like a DSU will work here. Okay, so what we can do is I think I know. Let's say we have 1 2 3 4, right? Like for example 0 1 2. So we have 0 1 and 2. Initially I will say like uh, initially they are all disjoint. So 0 is separate, 1 is separate, and 2 is separate, right? So they both have a very large value with them associated with them. So something like all the bits will be 1 1 1 1 1 1 1 1 1 1 and like that. And now when I said like okay, the distance between 0 and 2 is 7. So what will happen is 0 and 2 they both will become 7 because now they are connected. Okay. And now when we have 0 and 1 is 15, so 0 and 1 is 15, so but this value was 7, and when you add it, 7 and 15 is still 7, so this will also become 7. Then 1 and 2 is 6, so 6 and 7 is I think 0. 6 and 7 is 6, so everything will become 6 now. And then we have 1 and 2 1, so I think 6 and 1 is 0 because even an odd number. So this will become 0, 0, and 0. So I think the answer is 0 because if you have any two nodes, we can always make a path from 0 which will take 6 and 1 and then reach the final point, and that is why we have a 0. So what I will do is I will make a DSU. So let's say we have this and let's have a DSU, and what we don't need is let's simply call this answer. We don't really need the set size, and since we have 10 to the power 5, right? So I just need the power of 2, which is just greater than 10 to the power 5. So 1 less than 20. minus, wait a second. So this value is much larger. Let's say 1 less than 16, 17. 16 looks good. One, two, three, four. There should be one more zero. So 16 is still smaller than 10 to the power 5. So I will take 17. So initial value of all these will be to the power 17 minus 1. So what I can do is let's initialize them with this mask, that is 1 to the 1 to the power 17 minus 1. Okay, and let's call it answer. Now this much is good, but answer of x is equals to answer of x and answer of y, and let's also take one more parameter w, the weight of the edge. So this looks good. Now answer of y is equals to answer of x, or I think I can just write it here, answer of y equals to the same thing, right? And I don't really need these two functions. I don't think I need these two. I also don't need these. Okay. So this is the DSU that I will be using, and yeah, everything looks good now. Okay, so first thing that I can do is, let's say, vector int the result, and DSU d of n plus 1, let's say, for I in range edges dot size. I will pass in three function, like DSU d dot merge. I will merge three things: edges I 0, edges I 1, and edges I of 2, right? And vector int answer for I in range query dot size. Now what? Once we have the query, I want to assign these two values. Okay, let's say if d dot same, I think it was same, right? First of all, or maybe I can do, let's say, int u is equals to query of I 0, int v is equals to query of I of 1. Now if u equals to v, then answer dot pushback 0, right? Otherwise we have the case when else if d dot same, okay, I think I removed that function, d dot find u not equals to d dot find v. So if they are not in the same component, then answer dot pushback minus 1. And in the else case, when they are in the same component, I will make one more function, int get and int y, or let's say int x only. Now what? If we have this, now return answer of find of x. So this will find the top component of the um, disjoint set and get the value of that. So answer dot pushback get of u or v, doesn't really matter, anything will work now, and then I can return the answer. So let's just copy this whole thing and paste it here. Compilation error, why is that? It should be d dot get u, not get u directly. Now let's run this again. So we have 1 and minus 1, and here we have 1 and minus 1, which is correct. Let's try to submit this. Yeah, solution gets accepted. Now Okay, I think I will give this code in the description, so or maybe in the pinned comment, so you can check that out. Now let's try to. And if you want to learn about DSU, I will also include the code in the I button, so you can also check that out. Okay. Now let's also see the last column, that is this one. Lexicographically smallest string after operation with constraint. Here given a string s and integer k. Define a function distance. Okay. Uh, so let's say, I mean, if k equals to 0, then we don't really need to do anything. So if my k equals to 0, then I will simply return s, right? Okay, now what do we do? Initially, let's say, I mean, I can, okay. So let's say we have some characters s1, s2, s3, s4, s5 till sn, right? And initially, let's say my answer looks exactly the same, s1, s2, s3, s4, s5 till sn, okay? And now I will try to make this equals to a, right? And uh, if the value like if this difference doesn't really affect my answer, like why not? But how do I get the value, like how do I get the distance? So if I have some character ch and its distance from a can be something and its distance from z can be something, so how do I get the minimum distance that is f? So the answer will be minimum of ch minus a comma, and I want to get the distance other way around also. So it will be equals to 26. I mean, uh, I also want to get the distance other way around from between two characters. I'm not really good at these types of questions. I mean, they are easy, but yeah, I generally get tricked and spend a lot of time solving them. Okay, so when we have such question, so generally when we have such question, I mean, there are literally just two ways to, like, let's say we have some character C. I want to make it equals to A, but I can either do it like this or I can go other way around the whole from CH to CH plus 1 till Z and make it like this, then equal to A. So basically I have two kinds of distance, C minus A, and the the number of operations it will take me to make it equals to just Z minus C, and then one more time to make it equals to A, the minimum of that, right? So what I can do is okay, let's say string answer equals to s, and I will traverse in this for I in range s dot length. Okay, and now, like, if can I change this k value? Yeah, I can change this k value easily. So let's first take the distance. The distance will be equals to s of I. No, it will be minimum of s of I minus the character, or it will be equals to that from here go the other way around, so it will be equals to z minus s of I plus 1, right? So basically I want to convert all the starting letters to a's. So whatever we have here, I want to try and converting this value to a's, otherwise I will simply decrease as much as I can. So if this distance is greater than equals to k, um, I mean, sorry, not greater than. So if this distance is less than equals to k, then what? S of I equals to a, and k minus equals to distance. Else, I will simply say S of I minus equals to k. Will this work? Uh, let's see. I think it should. Uh, Otherwise, this is equals to 0, and simply return the answer at the end. I think this will work. Let's try to run this and see. So we are getting Z. Wait, what? This is not good. I think because I changed S of I and not answer of I. So this should be answer of I. Yeah. So we are getting AAAZ, which is correct. Let's try to submit this. And yes, we have solved all the problems. Okay, so that was it. And uh, I think we are done now. If you have any doubts, you can tell me in the comments. I generally reply to all the comments. And yeah, that is it. If you want to learn about some graph algorithms, you can check out my graph algorithms playlist. I will also give it in the I button. And thank you. Thank you for watching the video. I will see you guys next time. Thank you.